This video is about diffusion, right? Diffusion is a very simple concept. Diffusion refers to the random motion uh, of particles, which cause it to spread out. Now, we're going to look at this. This is a very important concept. Why this motion is random? Random motion is caused by random collision. And now, why are these collisions random and not fixed? Because if you imagine a car going on a road, okay, there's a car going on a road, and there are several intersections. But this car is speeding and it doesn't stop at any of the intersections, right? One intersection, intersection, and there's no traffic light on these intersections. So this car, as it goes, eventually there may be cars that stop. But there also may be cars that don't stop and just decide to come and they crash, right? Now you have no way of telling what direction these cars are coming from and when they're coming. So likewise in particles, they will be traveling in a straight line, but they have no way of telling what their neighboring particles are, where their neighboring particles are coming from, and how fast they're traveling and when they're going to come. So eventually they're going to collide. And when a car collides at, at a different angle from the car, at a different angle to the car at which it collided with, both the cars are not going to continue traveling in the same direction. This is not going to happen. Right? They're both going to change direction. Right? That's going to be a resultant. So this causes. This is why a random collision leads to a random motion. Right? And now, why this causes it to spread out is because if you have a bunch of, imagine these particles, there's one particle which travels here, it bounces off this, bounces off this, bounces off this, bounces off this, right? And then bounces off. From here, it's traveled all the way here, right? So it's moved. So imagine there are a bunch of particles like this, right? Big, big particles. And they're all traveling. And then you have slightly smaller particles, right? Yes, some smaller particles. Some are traveling like this. Let's put the arrows in a different color. Right? So some traveling, some are traveling. Eventually, they're going to hit each other, right? Some are going to hit each other. Some are going to just pass by each other. And you never know. So, as they pass by each other and collide with each other, some of them are eventually they're going to bounce off this and then it's going to come here like this. So now eventually they're going to be equally spread. If there was a higher concentration of these smaller green particles on this side, right, eventually as they bounce off one another, eventually they're all going to move, somehow make it here, or they may move this side as well. After some time, a period of time, they're going to be equally spread out, right? That's so that there's no atoms, they have charges, right? So they want to ensure that the charges are equal and there's no imbalance in charge, which is what causes them to be equally spread out and not gathered up together in another place. That's what diffusion is at its essence. Now, an important concept to know in diffusion is that different substances have different rates of diffusion. Their rates change. This is because their mass is different, right? They have a changing mass. Example, if you consider a really heavy truck, right? You consider a heavy truck and you consider a car, they're not going to be able to travel at the same speeds. They can, but that's at a lower speed. At the higher speeds, they're not going to be able to compete with each other because the car can travel further because it's lighter, right? So that means that the rate at which it travels is different. Right? Likewise, the diffusion. And finally, a very important term to know is intimate mixing. This is when a gas and a liquid mix or diffuse into each other. Yeah, sort of like soda. Right? So this is the concept of diffusion. It's a very short concept, but it's a very, very important concept because it forms the basis for most of our concepts in physics and chemistry, even in biology.